Hi there. Right, let's take a wee look at just solving some problems involving scientific notation now. This is more like what you would see in an exam. Just a regular numeracy question, but it involves scientific notation. First of all, there's just a wee typo in the question here. The example 3 here, it says there are 5 times 10 to the power 9 red blood cells in 1 litre. It should not be 1 litre, it should be 1 milliliter. You have a lot of red blood cells in your body. Okay, so that should read there are 5 times 10 to the power 9 red blood cells in 1 milliliter of blood. And it makes part A make more sense now. Calculate in scientific notation the number of red blood cells in 1 litre of blood. Okay, so for that, if we remember that in 1 litre we have 1,000 milliliters. So 1 litre is 1,000 milliliters. So if I have got 1 milliliter gives me 5 times 10 to the power 9 red blood cells, then 1 litre is going to be 1,000 times that. So I want to multiply that by 1,000. So it means that in 1 litre I'm going to have 5 times 10 to the power 9 multiplied by 1,000. So if you do that on your calculator, you'll get 5 times 10 to the power of 12 red blood cells. So in 1 litre of blood, we have quite a lot of red blood cells. In example 3b now, it's a lead on from part A. It says, well, if we know how many red blood cells are there in 1 litre, how many red blood cells would we have in a human body? And I think here they're just taking an average human-sized body, and it's approximately 5.5 litres. Well, if I know that in 1 litre we have 5 times 10 to the power 12 red blood cells, well, the human body has 5.5 times that. So I'm just going to work out 5 times 10 to the power 12 multiplied by 5.5. And that's just very simple again. Put it into your calculator. 5 times 10 to the power of 12 multiplied by 5.5, and I get 2.75 times 10 to the power of 13 red blood cells in the average human body. Let's go on and have a wee look at example 4 now. Bit more involved. It says the mass of 1 atom of oxygen is thought to weigh 2.65 times 10 to the power of minus 23 grams. The atmosphere around Earth is thought to contain 1.08 times 10 to the power 18 kilograms of oxygen. And then I want to work out, well, how many atoms of oxygen approximately does that make? So what we have here is we have quite a wordy question. I want to pull out the key facts here. So I know straight away that from reading the question that 1 atom is equal to 2.65 times 10 to the power of minus 23 grams. Okay, so one atom of O2 weighs 2.65 times 10 to the power minus 23 grams. Incredibly, incredibly light. It says now that the atmosphere has got 1.08 times 10 to the power 18 kilograms of oxygen. Now, there's a bit of a difference here. In questions, we tend only to work with questions that have the same units. So the weight of my atom of oxygen is in grams, but my weight of oxygen around the Earth is in kilograms. So I need to match those units up. So either I want to use all grams or all kilograms. So what I think I'll do is I'll go to the side and I'll change my weight of oxygen in the atmosphere from kilograms into grams. So to do that, remember that 1 kilogram is equal to 1,000 grams. So all I need to do is multiply 1.08 times 10 to the power of 18 by 1,000, and that will tell me how many grams of oxygen we have in the atmosphere. So that would give me 1.08 times 10 to the power 18 times 1,000 is going to give me 1.08 times 10 to the power of 21 grams. So in our atmosphere, there's approximately that many grams of oxygen. I now want to work out, well, if I know what one atom weighs, how can I work out how many atoms there are in the whole atmosphere if I know the total weight? All I need to do here is I want to work out 1.08 times 10 to the power 21 and divide it by the weight of one atom of oxygen. So I'm going to divide it by 2.65 times 10 to the power of minus 23. So let's go to our calculator and work that out. So we've got 1.08 to 1.08 times 10 to the power of 21 divided by 2.65 times 10 to the power of, and remember and press your negative button here, of negative 23. That gives me quite a long number to display. So it's giving me 4.075 471 698 times 10 to the power of 43 atoms. Okay, so remember this question is asking us how many atoms approximately, but it then says at the end round it to a number of significant figures. Okay, so it wants it rounded to 3 significant figures. So what I do here is I just treat this as a decimal, the way I would treat it when I was doing significant figures. I'm going to count in 3 places. 1, 2, 3. I'm going to make my cut after the 7. The 5 tells me to round up the way. So that means it's just going to be 4.08. Now, it's not going to be 4.08 atoms because we've got this times 10 to the power 43 to take into account. So it would be approximately 4.08 times 10 to the power 43 atoms of oxygen in the atmosphere, approximately. Past paper example 1, and we only have one past paper example in this anyway. This is very typical of what you would see in an exam. So it says a sesame seed weighs 3.6 times 10 to the power of minus 6 kilograms. The weight of a poppy seed is 8% of the weight of a sesame seed. Calculate the weight of a poppy seed in kilograms. Okay? So again, quite wordy. Let's pull out the numbers, pull out the vital information here. So we know that sesame seeds weighs 3.6 times 10 to the power of minus 6 kilograms. Remember, that's the number 0.000036. So it's a very, very, very small number. The weight of a poppy seed is 8% of that. So all I want to do is work out 8% of 3.6 times 10 to the power of minus 6. So, just go to your calculator and do it as you would normally do any percentage question. So, work out 8%. 8% is the same as 0.08. So, 0.08 multiplied by 3.6 times 10 to the power of minus 6. And that gives me, oh good, it puts it straight into scientific notation anyway. It gives me 2.88 times 10 to the power of minus 7. So that means that one poppy seed is equal to 2.88 times 10 to the power of minus 7 kilograms. Remember also, when you're working out 8%, you could also have worked out 3.6 times 10 to the power of minus 6 divided by 100 multiplied by 8, or worked out 1% and multiplied by 8. You do it however you work out percentages as normal. Remember, you're allowed to use a calculator here, so it should be a lot quicker. And that is working with scientific notation.